Hi. Thanks for being here. Thanks for having me. I'm super excited to be here to talk about web components in general and web components with Angular, with React, and with Vue, and how they all play together. And yeah, we're going to look at it. There's a lot of content to cover, so I'm going to jump right in. Yeah, my name is Filip. I work at a company called Impact. We have an office in Copenhagen as well, and we're always hiring, of course. We do e-commerce for some of the largest brands, and I'll skip all this introduction stuff. I am a part of Google's Developer Expert program, where I sit with the Angular team and the Chrome team every once in a while, and that's about it. So the idea of web components, the promise that we want to deliver on, and that this talk is all about, is the idea that we want to be able to just write our stuff once and use it anywhere. So no matter what framework you want to use, or if you don't want to use a framework at all, we want to use web components. So web components are possibly dead, possibly the future. Are they good? Are they ready? That's what this talk is going to be. So I'll give you like the why are we even talking about web components. I'll give you a short like tech introduction to web components. Then we'll talk about how you can use somebody else's web component in your app, so in your Angular app or in your React app or Vue app, and we'll turn it around and look at Angular elements and similar frameworks for the other frameworks, where you can write your component in Angular and then kind of expose it or export it as a web component so anybody else can use it. So that's what this talk is going to be, and we'll jump right into the why. The big why is, of course, interoperability. We want to be able to write our component in Angular and then use it in React. We want to take the date picker that we found for Vue and use it inside our Angular app. We want to be able to just pick and choose the components that we like and not really care about how they're implemented. And that's what web components are all about. It is a standard, so it's part of the language, it's part of the platform that we work on, it's part of the web. And the fact that it's a standard or that it's a native thing actually is also a really cool thing in performance. So anytime the browser gets faster, your app gets faster. Anytime Chrome or Firefox or Edge or anybody, they come up with a solution that makes web components faster, your app's a lot faster. So it gives us all the performance of the platform. But also, it means that we don't have to ship a lot of code. We can just ship a minimal amount of code, and all the stuff with encapsulation and styles and all that kind of stuff is handled for us by the platform, so we don't have to ship code for that. And framework, it should just be an implementation detail. Like, if whoever has the idea for the next great date picker wants to write it in Vue or whatever, he should be able to choose just that, and you could use it in any app that you want. Web components are finally happening. It's pretty exciting to finally have green pretty much across the board. And now that that Edge is going into Chromium, it's going to be we're going to fill out the last through check marks really, really fast, and we can have it running natively without polyfills everywhere pretty soon. And talking about polyfills, there are polyfills available. So if you want to use web components with IE10 or old crappy browsers, other browsers, you can do that with polyfills, and of course you don't get the benefit of the native stuff, and you don't get the benefit of not shipping a lot of code, because we have to ship the polyfill, but it works, so you can have the nice experience for all your users, and a good enough experience for older browsers. So there are a couple of specs involved when we're talking about web components. The most important one, or probably the most known one, is custom elements, where you can define your own elements. So kind of like the browser gives us a div and a span, we can define our own elements and have hooks into when they're inserted into the DOM and when attributes are changed and all that kind of stuff. Then there's shadow DOM, which gives us encapsulation, so we can have styles from outside not leaking inside, and inside not leaking outside. So we can actually have stylable components, and you can drop them anywhere and be sure that it looks how you want them to look. Then there's the template element, where you can put some kind of DOM elements into your DOM, and they have no effect until you actually take them out of the template tag or clone the template tag and use the contents of it. And then there's ECMAScript modules for the idea that the browser now actually handles imports and exports like we are used to. If you write TypeScript, if you write Angular, I assume most of you do, you know imports and exports, and now it's actually finally in the browsers, and it's a pretty sweet thing. So putting all of this together, building your own custom elements could look something like this. So you make a class, you extend from the base class of all elements in the world, which is HTML element, and you get some callbacks for like when it's put in the DOM, that's the connected one. The disconnected one is the opposite, of course, when it's taken out. And you can choose what attributes to listen for, and whenever some of these are changing, then your attribute change callback is going to be fired. And the important thing, of course, is the custom elements that define the very last line, where you define that this class should be the class for your element, and your element, the tag name, is the first argument to that function. And the important thing to note is that the way you make sure that you don't break the web, and the web will never break you, is that all custom elements must have a dash in the name, and all browser or all platform elements will never have a dash in their name. So that way you're sure that whatever browser specs come up with, they will never collide with anything that you've built, and the other way around. So actually, if you define an element without a dash in it, the browser is going to throw at you. So of course, this is just a regular class. So if you want to do properties instead of attributes, which probably sometimes you want to do, you can just do regular class setters and getters for the properties on the element, and you can listen for whenever they change as well. And talking about properties and attributes, they're two different things. Attributes are the ones that you put on the element, like typically in markup, where you can pass only simple values, so typically strings, maybe numbers, but they're all like, it's just simple values. Properties can be anything that JavaScript can handle. So you can pass a function to a property, you can pass an array, an object, anything that's more complex. You can pass that to a property. So for an element, these are all the properties on input. I know you're not really meant to be reading all of this. Just to say there's a lot, even though we only saw that there were 2 attributes on the slide before when we actually defined the element. Some elements are reflected, some attributes are reflected to properties, some are reflected the other way around. It's not always obvious what makes what it is. You see that if you change the value of the input element, the attribute is not changed, but if you read the value out from code, it's actually changed, but if you read the value out through the attribute, you still get the old value out. So it's a little bit weird, it's a little bit cumbersome, and it's just something that you have to notice, that you have to handle yourself. Then there's content projection. So as an Angular developer, you're used to this. When back from the AngularJS to Angular days, we all learned that it was no longer called transclusion, now it's called content projection, and that's actually to align with the spec, with the native spec for custom elements or for Shadow DOM, where you can project content from when you're using the component into its template. We can have named slots where you put a name on the slot tag with an attribute, and you put a slot attribute on the stuff that you want to be able to put in that. So it's I know this is a really fast introduction, and I'm sure you can find it. You can watch the video later and slow it down a little bit, maybe. But I'll just run through the specs so we're all aligned. Then there's the ability to do styling. As I said, with Shadow DOM, styles are encapsulated. So if you put an H1 inside of your custom elements or inside of your Shadow DOM, the global styles for H1 are not going to apply. And if you put style tags inside of your Shadow DOM, it's only going to apply to elements inside your Shadow DOM. It's not going to apply to the rest of the world. The way you then actually make an API or make your component stylable is currently through custom properties, which is something that we've talked about for years. We've more or less called them CSS variables, but they're actually a little more powerful than that. And that's some of the only thing that actually pierces the Shadow DOM are custom properties, because they don't do anything in themselves. But that's how you make an API. That's how you define that maybe you can have a header color or something that you can define as a custom property, and you can use that inside of your local CSS. Then there's some special selectors for selecting the host element itself, or for selecting content that's actually been slotted in. And then there's a new spec for parts, which is, if you're used to Sass, it's kind of like a mix-in, where you can put in like a set of attributes or a set of properties with values and pass them in as a part. And then from inside your CSS, you can actually use that part in there. So that's not supported anywhere yet, but that's the future of where we're going, and I think that's the missing piece that we need in terms of styling for custom elements. Yes. So with frameworks, that's actually the first more like specific to Angular thing that we're going to talk about. So we're going to talk about how we use custom elements or web components that somebody else has written, or you can write them yourself, but somebody else's components that you don't know anything about, you want to be able to use them inside your framework. Throughout this talk, we're going to look at Angular, Vue, and React and try to compare them to each other. So I built a very simple custom element. It doesn't really matter what it does. It's just demoing out some of the features. So there's some content being slotted, and there's a custom event being fired, and there's some styling that doesn't apply anywhere, and all that kind of stuff. And it has data as an attribute and data as a property, and it listens for an event that has a camel case or a camel cased event. So pretty standard stuff. What we want to do is really compare how the frameworks can use web components like out of the box, how feature complete they are in interacting with web components. Everybody's great friend Rob Dodson, he works with Google, and if you've ever looked for anything on the web with accessibility, you've probably found him. He's a great guy, and he maintains this website called Custom Elements Everywhere, where he has automated tests for all the use cases that we want to do, and that's actually some of the scores that we're going to take a look at today and see how the frameworks score on these skills. So, as I said, we want to be able to just put a custom element inside of our template, like we would put an Angular component inside of our template, or in React, we would put a React component inside of our JSX template, or in Vue, the same thing. We want to just be able to put a custom element inside of our template and just use it like it was a regular component. So that's what we're going to talk about. In Angular, in able to use custom elements, you have to define it on the module that you want to use the custom element schema, otherwise the compiler is going to yell at you because it doesn't know what tag it is or what component it is. So that's just a thing to note. And then the rest of it is just like using a regular Angular component. So we just have a template where we put our my element in, which is the web component that we just built. We bind to the property as Angular, when it sees an element that it doesn't know what is, it's just going to bind to a property by default. So when you do the square bracket binding that we're used to, it's going to bind to the property of the element, just like we expect. If you want to bind to an attribute, you put attr dot in front of the binding, and then it's going to bind directly to an attribute instead. Pretty standard. Listening for an event is just like listening for an Angular event, so you put the event name in the parentheses, and that adds the event listener for you and calls your function, and all that kind of stuff is great. So on custom elements everywhere, and in all the tests that I've done, Angular scores 100% on using custom elements. It's just a perfect fit. With Vue, it's a very similar thing. So you see this is the single file Vue component, which is how we typically write Vue. And in the template in the top, you see that we just put the custom elements in, like we did before. The syntax is a little bit different. We use the colon in front of the name, and by default, we bind to attributes, so we have to put the suffix of .prop in order to actually bind to a prop. But it's the same thing in Vue. Events are the same. You put an @ sign in front of the event name, and it calls your function. The rest of it is history, as you say. And Vue actually also scores 100% on working with custom elements. For React, it's sadly a different story. I really like React, but they still have some catching up to do when it comes to web components. You put the element inside of your template like this. This is JSX, so we just put it in right inside of our JavaScript. And when we do this, React currently doesn't have a way to bind to a property of an element. So since we're binding to an attribute here, we're just going to get an attribute called audience prop with the value of object, because it doesn't know what to do with the object. So it's pretty much useless. The attribute binding is straightforward. That works out of the box. And the event syntax in React is different. So here we say custom event, but since it's actually being passed through the DOM and all attributes doesn't include case, we can only listen for lowercase events. So as soon as there's any uppercasing inside of your event name, it doesn't work. So for React, sadly, it fixes all the basic tests, which is just like the framework doesn't die or it doesn't throw an error at you when you put it in. But all the features that you actually want to do, it fails. So you see 0 out of 14 of the advanced tests, which is setting properties on elements and listening for custom events. So yeah, you see, these are all the tests that are failing, and they are in regards to properties, attributes, and events. To be fair, there is talk about defaulting to properties instead of attributes in React 17, but who knows? We never know what's going on with React. Yeah, you can find the blog post here, which is from the official React blog. Preact is a framework that's similar to React. It started out as being a drop-in replacement. Now it's more or less a different project. But Preact actually does a lot better here, primarily because it allows binding to properties instead of attributes. I'm not going to go too much into this, just to say that it's not impossible to do. React should be able to implement this, and it shouldn't really break a lot of stuff for it. Preact still has the problem with events. So event names can still only be lowercase, or you can do kebab casing or something where you put a dash in the name. That's fine as well. But you can't do anything that must have capitalized letters in them. So of course you can do it yourself. Like you can just grab a reference to the element and set a property on it directly, or do an add event listener and listen for whatever event name you want to do. You can do all of that. Imperatively from your code, but what we're trying here is to see how can we do this declaratively. And React currently doesn't have a really good story about that. There are wrappers out there that does this for you, so you can wrap your custom element inside of another element, and then it handles all of that stuff for you. So that's the first part, which is how to use custom elements that somebody else built inside of your app. But the really important thing, the thing that I'm pretty excited about, or most excited about, is the ability for you to write your application in Angular or in Vue or in React and then expose it as a web component so that somebody else can use it and they don't have to know about Angular, or they don't have to know about how you implemented your component. They can just use your component. I think that's pretty exciting. Again, as I said, the main thing we want to take away from this is interoperability. We want to be able to just write once and use it everywhere. Framework should just be an implementation detail. And it should just be something that the component developer chooses because he likes that stack, or he likes the tools, or for whatever reason that he has, or she. So there are two different ways of doing this. Some of the modern frameworks out there actually does web components as how they do their stuff. So frameworks like Svelte, Stencil, LitElement, Polymer, they're frameworks that are actually built on top of web components, and they work like this out of the box. But we're talking today about primarily React, Angular, and Vue, and none of those work with that out of the box. So they all have, or we want to take a look at how we can wrap our Angular component or React component or whatever inside of a custom element so that anybody else can use it. So we want to just wrap it in a custom element so it's publicly available. We want to be able to just pass a property to the element, and then the element should do all the magic of passing that to Angular and doing change detection and all that stuff. We want to be able to just listen for regular DOM events. So whatever you do inside of your framework should just emit regular DOM events for when stuff changes. We want to be able to just use slots and have style encapsulation and all that kind of stuff working out of the box. So the comparison that I've done here is we're looking at the basic features. So we're looking at how do we work with styles and CSS encapsulation. The slot works out of the box. Can we do properties and events for inputs and outputs? That's the names we use in Angular, but you get the idea even if you don't know Angular. And we're going to look at how easy is this to use. How does it feel? Does it feel like it's a sweet thing? How simple is it? And then we're going to look at the size of the bundle that we're getting out of the framework. We're not going to look at the framework integration. So a lot of what makes Angular elements hard is how do we deal with dependency injection and all that kind of stuff. But that's just impossible to compare how that works in React compared to how it works in Angular, because it's a completely different story. So we're going to look at just the interface of how you work with the component that you get out of it. Just to be fair, I know there's a lot of work in Angular elements, and that's what's really hard about it. So For Angular and Vue, there are official wrappers. So for Angular, we have Angular Elements. For Vue, there's a similar thing. For React, there's no official way to do this, but there are a couple of community projects. I took a look at one of them, and probably you know that some of the other ones are better, and that's fine. But we're just going to look at one of them today. And if you know which one is better, you should come talk to me, and we'll take a look at that. We'll build the next demo in that one. So we're building a custom button component. It takes a label as a property, so you can put like the label of the button in. It also has a slot, so if you fill in the slot, it's going to use that instead of the label. If you don't use the slot, it's going to use the label. It just has a button where it counts the amount of clicks that you put on it, and every time you click on it, it also emits a custom event that we should then be able to listen for. And then we have, in order to check the styling, it has an H1 and a styling that only applies to H1. And then there's an H1 and a styling to H1 in the global scope, so out of the element, and we want to see that they don't interfere with each other. So using it is just something like this. So we have the header outside with the H1 that's global, and we have the custom button being used. We use the label as an attribute here, and then we have some content that we want to be projected. So for Angular, there's a project called Angular Elements. I don't think that's a surprise to anybody. You add it by just adding at Angular Elements, and you're pretty much good to go. So if you want to be able to have the native style encapsulation that we want, you need to set the encapsulation in your component declaration to viewEncapsulation.shadow-DOM, which just tells Angular to keep out of this and just put the styles within the template like you want it to be. Other than that, this is a very simple Angular component. You see, it has the input for label, it has the output as an action that emits an event, and whenever you click it, it increments the counter and emits the event. So it's a pretty simple component. The component is not really the thing that we're focusing on. So in order to make this work, inside of the module for the component, we use a function that we import from Angular Elements, that is create custom elements. We pass the Angular component to it and the injector, and then it returns the actual class that we then call custom elements.define with. So that's how we do it, and that's how we get a global component or custom element that's based around your Angular component. With Angular, this is really simple. This is just a video of me trying it out. You see that there's the red header outside and the blue header inside, so the style encapsulation works. If we query for the element, we can actually listen for native DOM events. So I think the event name is action here, and then we just log it to the console here just to see that when we click the button, we actually get an event that contains the number that we've hit. So you see that now I click it, and we get the number out. So Angular pretty much works this way, so you can pass properties to it. You can use shadow-DOM for encapsulation. We can pass events, and it does it as regular DOM events instead of Angular events when it hits the custom element. So one thing to note is that, as I was saying before, Angular has a similar thing for content projection called ng-content, and then there's the native slot one. So if you want to be able to use some of the fancy features of querying something inside of your that's been projected into you from your component, you should go for ng-content because it does a lot more stuff. But it is kind of hard, and it is a little bit harder to understand, and it also makes your bundle size bigger because it needs to have a lot more code. And typically, we just want to be able to just put the content in and don't worry about it. And for that, the native slot tag is easy peasy, and it works just out of the box. To be able to have the minimal bundle size that we can, I disabled ng-zone. That's also why, if you saw the code, I was doing manual change detection whenever the button was clicked, just to be able to have the bundle be as tiny as possible. And that's how the other frameworks do it out of the box. You have to call setState or do something in React to get a similar thing. So for Angular, this is the current result. So the bundle turns out 50 kilobytes of JavaScript is needed to actually get a web component running with Angular Elements. You know, everything's better in Angular with Ivy, and you know Ivy is just crazy magic, and you don't really know what's going on, and it's tough like that. With Ivy elements, smaller, simpler, faster, everything's better with Ivy. You know, but we don't know and nobody knows when Ivy is really ready and that kind of stuff. At ngconf, there was talk about potentially being around 50 kilobytes of code for the equivalent component with Ivy. But I haven't been able to actually make a demo work with Ivy. It's still too hard. I talked to Rob at when I was at Google I/O the week after ngconf, and he failed to actually produce a demo that was working. So we'll see how that goes. Don't hang me on the 15 kilobytes, but absolutely when you talk to Rob, tell him about that and tell him that's what you want. There's talk about using Angular elements for lazy loading, on a component level, and I think that's a really excellent use case for using Angular elements even inside of an Angular app. So I'm pretty excited about that. So for Vue, there's a similar project called Vue Web Component Wrapper. You add it by npm installing it. You write your component like you would any other component. You don't have to change anything. And then inside of your main bundle, this is very similar to Angular, right? So you get the wrap function from the wrapper library that gives you back the custom elements that you call the custom elements that you find with. Styles are weird in Vue. As you see, it doesn't work. That's because when you do the single file Vue component, the style tag is automatically hoisted to the root, so it just puts all the styles in the global scope, which is not what you want. Then there's the style. You can put a scoped attribute on the style tag, which just turns it into CSS modules, which is still global and still doesn't apply. So there's currently no way to really do this in Vue. Of course, you could you should think that you could just put a style tag inside of your template, but Vue specifically disallows putting anything that adds styles inside of your template. So there's no way to do this. When you look at the website, they say when you want to do custom elements with Vue, you should use something else for styling. So building Vue, the main.js file that I was explaining is just for when you're developing. When you actually want to build it out, there's a specific command in the build CLI that you call, and it's built all for you. With Vue, it feels really good to use it. The setup is a little bit hard with the main file and the other thing for building it, but you get used to that. Then there's a weird thing where the detail object of the custom event actually has an array with only one item in it, which is the value that you're sending. That just feels weird. Why is that necessary? But I guess it's due to how Vue handles events internally. As I said, it doesn't handle styles. And the bundle is tiny, but then it needs a global Vue instance. Which I think is a little bit weird. And because we don't know anything about it, it can't be tree shaken, so we just need all of Vue. Vue is still tiny, so combined with the entire Vue instance, it's still smaller than the current Angular elements. It's actually the smallest thing that I've been able to do is still this approach, but it doesn't handle the styling, so it's not really complete. So for React is a little bit different, right? So typically we don't have custom events. We pass functions, or we pass like callback functions as properties. We do CSS in JavaScript anyway. How do we do this? There's a whole lot of projects that tries to do this, especially the two in the top that are very similarly named. I think that's a little bit unfortunate. I spent some time trying to debug one, reading the other one's manual docs. That was just weird. But I think we should take a look at web React components. It looks like the real deal. It seems to not be maintained. There's not a lot of activity on the GitHub issue, and it's not complete, so I don't think that's why. It does work a lot like the other frameworks does. So it has a register method that wraps and registers your elements. For React, typically we have props.children, which is the stuff that you kind of like content projection. But props.children here is just a slot tag, which is a kind of a nice and easy way to get this working, but that means that we can't really have any default value because you can't put anything inside of the slot tag because it's being fed this way. So if you want to use content projection, you should just probably write the slot tag yourself. Styles, you can't really do it. It's the same thing. So the workaround is to put a style tag on it. And if you try to put rules inside of the style tag like you normally would, JSX is going to throw up at you. So you can do it through dangerously set inner HTML and actually put the value in as a string. That's also a wild hack, but that works. So you add it by npm installing it. You write your React app as you more or less typically would. And you see here in line 20 is the hack with the dangerously set in HTML, which is what we need to actually get the style working. You register it just like the other frameworks, but you see that there's more than 2 arguments being passed to the register function here. The first one is an array of all the props that should be handled, that should be translated between properties on the element to props on the React component, which is a really nice and explicit way to say what you want. And the other one is the translation between callback functions being passed as props to regular DOM events. So I think this is a very nice way of handling the fact that the framework uses some of these patterns a little bit differently and still have it a standard way exported. So I think this is a really nice way of doing it. It works, as you see, just like the other frameworks like this, although, as I said, the styling is a big hack, but it works. And the bundle size for this is just about the same as Vue. It's like 2 or 3 kilobytes larger, but it's about the same. We won't have time to go into the other ones, so I just want to take a look at the result before we finish here. So we see on consuming elements, Angular and Vue are the clear winners. React kind of suck at this, and I really hope that they will catch up to this, and I think they will. For wrapping, when it comes to features, Angular are definitely the most feature-complete one, but Vue and React actually feels better. Like when you work with it, like the APIs and stuff is just really nice to work with. And the bundle size, I really wish I could write 15Ks and have Angular beat all the other ones to the end of the world. But currently, Angular really stinks when it comes to bundle sizing for Angular elements. So this, of course, leads to the question: do we even need a framework? Like, can we just use web components alone? And you can. You probably want some kind of sugar on top, some kind of really lightweight framework, like I was mentioning before, LitElement, Stencil, Svelte, something like this. And you need some helpers below, probably something like for state management, for doing utilities for routing and for HTTP state management, all that kind of stuff. So this is more the React approach, where the framework is actually just a component model, and you pick and choose whatever you want to use. You can absolutely use that today. The platform still has some gaps to fill. I was talking before about the parts API for styling your apps. We still like something like scoped registries, because currently when you define a custom element, it's by definition a global element, so you can't have two different elements with the same name. So if you want to use a component and they depend on another component that has a name that you already use, you're going to have a collision and it's just not going to work. And something like import maps for the native imports and exports, so you don't have to define the very, very, very long URL that's a definitive URL to the module that you can just do like we're used to, and Webpack will handle it for you. We just want the browser to do a similar thing, so you can just have aliases for your imports. So as the conclusion, my final slide, this is a very interesting area. I think this is going to be the future. It's almost here. So you see, like it's still like the bundles are still a little bit too big, and the features are almost ready. I think we should start using it as soon as we can. We should push the frameworks and tell them this is what we want. This is how we're going to get the future, the thing that we really need, where we can just write our component once and use it everywhere. If you want to play along with it, all the codes to all the examples are on this GitHub repository. Please file issues, submit a pull request if you want to do this with Skate.js or with some of the other React projects. Absolutely, I'm happy to put more examples in there. This was frameworks and web components. Find me on Twitter, on LinkedIn, or wherever you want to go. Come talk to me in the break, and that's it. Thank you.